We are recording. All right. So we're continuing our discussion of work and force. We have two main types of problems that we're going to work on today. First type is to calculate the work required to move an object along a linear path where the weight varies as the object moves. These are basically your chain problems where the weight changes as it moves. And then the second is to calculate the work required to move liquids in various shaped containers, various distances. That'll be fun, right? Okay. Not pushing the containers, but like literally pumping the liquid out of one container and putting it somewhere else.
Pushing the containers.
All right.
Pretty easy.
Okay, so we did warm up before we turned on the camera that dealt with the chain problem. So here we go. We have a chain. It is 30 feet long. That 30 feet of chain weighs 50 pounds.
That's heavy.
Yes, it's a heavy chain. The chain is hanging from a winch that is 30 feet above the ground. How much work is required to lift the chain so that the last link is 10 feet above the ground? All right? Okay. So we're winding in the chain. Remember in the warm-up problem we gave you the weight of the chain in pounds per foot, right? So you'll have to figure that out. It's not too hard, pounds per foot. Okay? And then remember, it's the integral of the weight times the distance that the chain is, basically the length at any given time. So it's really the integral of the force, which is the integral of the weight, which is the pounds per foot times the number of feet at any given time. It's really similar. Pictures can help.
Oh, is it chain? It's chain. Oh, it's touching the ground.
So you have ground. Chain, and it's being, this is 30 feet. And that's I'm having trouble with my board today. Elton John is not in this problem. Close lids, get to work.
Sean would know if he was or if he wasn't.
I've also never seen Star Wars.
Oh, I'm proud of the fact that I haven't seen Star Wars.
Have you seen the Disney movie?
I have one.
Come back here. See how we're doing back here.
I don't know. How did you know that?
Have you found pounds per foot? Okay, good. So we know that it's pounds, 5/3 pounds per foot. Now you need to figure out if y equals 0 is the ground, and say at any given value how much chain is there that's hanging off the winch for any given y value. It's not terribly crazy. Say my chain is hanging 5 feet off the ground. How much chain is there? Yeah, right? So if my y is 5, the length of chain is 25 feet, right? If my y is 10, my length of chain is 20 feet. So in general, how could I write a function to give me the length of the chain? And then so then the weight of the chain would be 5/3 times 30 minutes.
Oh, I gotta make something.
Now, is it from 10 to 30? Is it from 10 to 30? So, remember guys, can y'all stop talking? We are going till the last link is 10 feet off the ground. Remember that this is a y value of 0. 10 feet off the ground would be to a y value of 10. So, what we've got here, so we have the total weight is 50 pounds, so the chain's weight is 5/3 pounds per foot. The weight of the chain at any given y value is 5/3 times 30 minus y.
That's what happened.
So our integral our work would be the integral from 0 to 10, because we're only going from y equals 0 to y equals 10. So the integral 0 to 10 of the weight of the chain, and you end up with 12/53 foot-pounds. All right?
Oh wait,
Right.
10.
That's probably right. Yep.
We'll get calculators.
Yes, this is all calculated, the whole unit. Yes, Kate?
If the chain was longer than the winch was high, what would you do?
The first part of your integral would all be the full weight of whatever chain is there.
You said negative.
I'd probably do two separate integrals, one with just the full weight, and then one once it starts to reduce.
Oh, I see. Okay.
Yep. Okay. All right. Here we go. A cable.
Seems like a distraction.
A cable that weighs 2 pounds per foot has a bucket attached to the end filled with 800 pounds of coal. The bucket is sitting at the bottom of a 500-foot mine shaft. Calculate the work required to raise the bucket halfway up the mine shaft.
Someone's body this year.
500 feet. People that we
People like holding the
Remember, it's the integral of the weight at any given y value.
Oh yeah, but like
Yeah, do that. No, it's gonna be like. Yeah, because you get this.
Yeah, I would treat 0 as the bottom.
Yeah, so it'll just be 200 divided by 800.
Wait, that's not right. Isn't it just the same thing before and then added?
That's what
That's just the row. That's the row. So then you need to.
Yes. Yeah, that works. Yep, dy. Right, you're using x, so that's not just the x.
387 pounds.
We'll call the bucket weight.
The integral from 0 to 250.
Oh, it's
2 times 500 minus y plus
get why you have to add these.
because there's 800 pound bucket at the end. And you have to find the weight of the cable plus the bucket.
It's not changing the weight, yeah, it's the same.
Okay. 3875. 0 to 250. Of 2 times 500 minus y. No.
Yeah.
That. The
It's
800
integral of
and the integral
the
and the
weight
two.
that you're using up.
Jeez, we stuck it.
Yeah, the 800 is constant. Let's get that. All right, let's take a look. So the weight at any y value is 800 plus 2 times 500 minus y. And then the work is the integral from 0 to 250 because we're only going halfway up the mine shaft, right? 0 to 250 of the weight that we are lifting. So our total work is 387,500 pounds. Okay? Does that make sense? Yeah. Okay, everyone good? All right, good. Don't worry, we're going to leave chains for now, but you will get to do another one today just for a little bit more practice. But we're moving on to tanks.
No.
Okay. Here we go. Erase stuff. All right, now, I'm going to walk you through this step by step. I want you to follow these steps every time you see these problems. Are you ready? Are you ready now? Yes. Okay. Here we go. An open tank has the shape of an inverted right circular cone. The tank is 8 feet across the top and 6 feet high. If water is being pumped in through the bottom of the tank, how much work is done to fill the tank to a depth of 2 feet? And how much work is done to fill the tank from a depth of 4 feet to a depth of 6 feet? For the weight of the water, you may assume that water weighs 62.4 pounds per cubic foot. That is a number you're going to want to learn. 62.4 pounds per cubic foot for water. That's a lot. All right. So, here's the thing about these. In order to find the weight of the water as the tank fills up, the way that you do it, kind of like the chain, you did the pounds per foot, right? Times number of feet, basically. Here we're doing pounds per cubic foot times the number of cubic feet that have filled up into the tank, right? There's a little gotcha though, because you have to take that and then also, in addition, multiply it by the distance that the water has to travel, if the water has to travel. In this case, it gets to stay in the tank. In the next problem, it's going to be leaving the tank and going to a separate place. So anyway, so the first thing we have to do is figure out basically our weight of our water for any given y value. And the way that we do that is we're going to take the container and slice it into little teeny cross sections, and we're going to add all those cross sections times the weight per pound per cubic foot together. So basically we're going to take this container and we'd be slicing it into little mini cylinders. Remember when we did volume of the container? It was basically the same thing. We sliced it into a million little cylinders and added all the cylinders together, right? So what we have to do here is just find the area of the cross section, and then the height of the cylinder is going to be our dy. So the big part of these problems, the first part you always want to do is figure out your weight of your water in the tank for any given y value. And it's, so in this case, let's just say, I don't know if I want to draw, I tried drawing a cylinder this morning. It didn't work that well. That's like what we're talking about, these little mini cylinders, right? Okay, so for a cross section, volume of a cylinder is pi r squared h, right? So we need the radius and the height, but the height's going to be our dy. So the radius of the cylinder, if this is r, and this is, let's call this y, because we're going to do it in terms of y. So if this is r and this is y, we need to find a formula for the area of that cross-sectional circle, but it has to be in terms of y, not r. Everything has to be in terms of y. So here's what we get for our water. We have the 62.4 times pi times something squared. Normally it'd be pi r squared, but we can't use r. Is there a way that we can relate r to y?
No.
Yes. This is with proportions, right? We have similar triangles, so we do just a little proportion. R to y equals 4 to 6. Oh, that's the loopy. 4 to 6. All right. So anyway, so r is 2/3 y, and that's what we put in here. So what you need for your cross section is you need the weight of the water pounds per cubic foot times the cubic feet, this is really square feet right now, of a cross section, and then this dy gives you the depth, right? Okay, this would be great, but then we have to take into account the fact that the water is pushing more water up and it's traveling a distance. So what you have to do when you're doing these, so, oh, look, there's, okay, so there's our blah, blah, 62.4 times the volume of each little flat mini cylinder, right? All right, so when you do your work, this is your force times the distance the water has to travel. In this case, as the water is traveling for any given y value, it's just going up a distance of y, because we're filling from the bottom. So the next, like, say the water is just sitting in here this full, so the next bit of water has to go up a distance of y to add to it. And it keeps traveling up a distance of y. So in this problem, our setup is going to be the 62.4 times the pi times 2/3 y cubed dy times the distance the water has to travel, which is y. So the three parts you have to deal with for these problems. The first part, and this is the hardest part, part 1 is finding the area of the cross section. And it has to be in terms of y. Alright, so that's the first part. You find the area of the cross section in terms of y, multiply it by the weight of the water in pounds per cubic foot, or whatever the units are that are given. The next part is you take this now, put it in your integral, and you have to multiply it by the distance that the water has to travel. In this case, the water just has to travel a distance of y.
What's another example of a distance?
That'll be the next example. It'll be fun. Just wait, you're gonna love it. Okay,
Sarcastic.
then a little. Then the third part that you have to do is figure out your limits. The limits are always within the container. So if within the container the liquid is going from a water level of 0 to a water level of 2, because for the part A we're filling just the first 2 feet, then we're going 0 to 2. If the water level in the container is starting from a y value of 4 to a y value of 6, which would be part B, then we're doing 4 to 6 for our limits. The limits deal with the level of water in that container, the height of it, the y value.
Isn't that kind of common sense?
I hope so, but the next problem, it's not going to be quite as common sense.
Okay.
Okay. All right, so anyway. So for this one, the first one just said how much work is done to fill a tank to a depth of 2 feet. So there's your set, 0 to 2, weight of the water times the volume of the little mini cylinders, which is your area of your cross section in dy, and then times the distance the water has to travel. How would this change for part B, which is just to how much work is done to fill the tank from a depth of 4 feet to a depth of 6 feet?
The limit would be 4 to 6.
The limits are 4 to 6. That's the only difference, right? Now, the fun parts of these problems are that the tank can be any shape at all, right? So,
Love it.
yes, I mean, the tank can be shaped with functions that define the outsides, right? The tank can be shaped with any shape at all that comes into the mind of the person who's writing the problem, right?
Which is
Okay.
Thomas, he has a great track record.
Yeah.
All right, yes.
So the area of the cross section touches this circle.
In this case, the slices would be circles because it's a cone.
cylinder.
Well, it's a cylinder because you have that dy.
It's this tiny cell.
All the DYs.
Yeah, the dy is what gives it its height.
Okay.
Yes. All right, but it's basically
Elsa, give
it's
me a
taking a
quote.
cylinder, but it's taking it as that height approaches 0. It's a flat, it's a disc. Okay, now, yes, sure.
I just want to see the question.
Oh,
I got it.
you sure? Any other questions before we move on? All right, the next one's really fun. I'm going to walk you through it slowly. So, the fuel tank on a truck has a trapezoidal cross section with dimensions in feet shown below. assume that the engine on the truck is approximately 3 feet above the top of the fuel tank, and that diesel fuel weighs about 53.1 pounds per cubic foot. Find the work done by the fuel pump in raising a full tank of fuel to the level of the engine. So what we have is we have a full tank. We're going to empty the tank and pump the fuel up to an engine that's 3 feet above the tank. All right, here we go.
That's really hard.
Okay. Yeah. So here we go. Much as trucks want you to manually empty the fuel and then walk over and pour it into the engine, fuel pumps. Okay, so here we go. First thing we have to do, and remember the hardest part,
Area of the cross section.
is finding the area of the cross section. Okay, so guys, look carefully. We're slicing this way. What shape is the cross section?
Rectangle.
It's a rectangle, right?
Changing.
Okay, it is a rectangle that's changing size. However, the length of the rectangle is always what? 3. So all we really are concerned with is the width. We have to find the width, which is this distance. We have to find the width in terms of y. Now I'm going to draw this sideways for a minute. Okay, so that's this side right here, right? Because the rectangles, right, we're going this way.
Yeah.
Right, so whatever. Okay. So anyway, so we need to find this distance in terms of y. And I'll even give you a hint. So from here, right, this has a length of 1, and that stays consistent all the way through. This here, from here to here, pretend it's not dry scale, has a length of, oops, also 1. The total length is 2. I can't erase without destroying it. Well, I'll try. All right, so, and then of course the height of the whole thing is 3. So your job right now is to find a way of figuring out that width in terms of y.
I don't know.
It's just like the last problem. It's 1 plus.
Yeah, that's why you gotta rewrite.
1 plus 1 third. Hey, okay. That's not the best.
No, I.
I'll even give you a little hint. If you call this, like this is 1, call this little part A, and that height y. See if that helps you.
It's rectangle. dy. But we can't go much farther than that. We don't know what we're doing.
You don't know what?
Is that all we're doing right now?
Right now, I just want you to figure out how to find the area of the cross section.
Because we don't know how to do it.
I'm very visual.
That's why she drew a picture.
I mean, like, after she doesn't know how to do it.
That's not a picture.
That's not visual.
I'm a very memorizing learner. I'm really good when people show me the answers and I recite them.
That's my process.
Alright, so it's another proportion, right? Just like the last one. So you have A over Y equals 1/3, so A is 1/3 Y. So the area of our rectangular cross section is going to be 3 times 1 plus 1/3 Y.
Hey.
Does that make sense? Alright, so,
Do this.
alright. So your total force that's
Still didn't make
from the weight of the water is that 53.1 pounds per cubic foot, or sorry, fuel, times 3 times 1 plus 1/3 Y, which I wrote as Y plus 3 over 3. It's the same thing, dy. Yes.
Can you go over the area again?
Yeah, so the cross sections, right, are these little, they're rectangles, right? So this length is always 3. So we need to find this width. I didn't but the width is going across this way. So I kind of drew this trapezoid, because from here to here, each side of the trapezoid, that's the width of the rectangle. So we needed to find this distance for the width of our rectangle. Well, this distance from here to here, it's always a 1, right? So we have 1 plus whatever this little guy is right there. So we can put 1 plus A, but A is meaningless in this problem. Everything's in terms of Y. So we did similar triangle proportion to solve for A, so that we could have 1 plus 1/3 Y instead of 1 plus A.
It's like focusing on this man's face.
Is that?
Yeah.
Okay.
Like a box.
Alright, and then
It's like
times
the
dy
area
to give it depth. Yes, no.
Is that little thing you just drew, is that like this side?
Yes.
Yeah, I got it. Here, I don't mind erasing it. I'll clean it up later.
If any of you needed John,
Actually, no, no, no.
advertise.
On the video.
Call Sean Paul for a job if you want.
Yeah.
$8 an hour.
There we go.
Hit
So
me up
yeah,
on
this
Insta.
cross section right here is this right here.
Yeah, oh.
Alright, good. Other questions?
Yes.
And it's like on the bottom of the page.
Don't we need to also multiply by like the water going, or the gas going down and like the distance?
We're gonna do that, don't worry, that'll come into play. This is, right now, we're just talking about getting that water weight at any given value of Y. The weight of the water that, or the fuel that's in the tank, right? Okay, so now we've got that, right? And then here's the integral setup. Integral is the force times the distance the fuel has to travel. We have a fuel pump, or I'm sorry, we have an engine that is 3 feet above this tank. So we have to go up another, 3 feet for that fuel, right? Think carefully. If the tank is full, then that means our Y value is 3, and the fuel has to travel 3 feet. If the Y value is at 2, the fuel will have to travel 4 feet. If the Y value is at 1, the fuel will have to travel 5 feet, right? If the Y value is at 0, the fuel will have to travel 6 feet. So can anyone figure out a function for how far the fuel has to travel? From top to bottom, what's the total distance? 6. It's 6 minus Y. 6 minus Y.
Oh, yeah.
Right? Just think about it. The whole thing is 6, right?
Plus 3 minus Y.
If Y is 0, it has to go 6 feet. If Y is 3, it has to go 3 feet, right? It's 6 minus Y. So, we end up with an equation. Here's our cross section, right? This right here. And then the distance the fuel has to travel is at 6 minus Y. The last thing you have to deal with are your limits. The limits deal with the top to bottom values for the Y values of the fuel in the tank that you want to take away. So say we were only going to be removing the fuel from Y equals 2 to Y equals 3. We just go 2 to 3, right? But we have to empty the whole tank, so we're going 0 to 3. So it's just in the vessel that you deal with for those limits, not vessel to engine.
What was your first example? If we were just doing like 2 to 3, what would we do?
You literally have limits 2 to 3. Now, the hard part, not for this problem, just to give you a coming up, like fun preview, is you might see problems in the future where it'll say something like, how much work has to be done to remove 1/3 of the fuel. You have to figure out what Y value causes you to have 1/3 of the tank removed by volume, right?
Oh.
So these aren't clear cut, it's not just taking Y and dividing it by 3, right? So,
You have to find the volume of the
yeah,
whole
so
thing.
these are gonna be really fun. They get more and more fun as time goes by, right?
Just like math.
Yes! Yes, okay, now, we're about to do some in our groups, but before I kick you off into your groups, I wanna show you something. Okay, the problem that you're about to do, the tank, it's fun, it's a twofer, okay? You love problems where they have you do 2 completely different problems in one problem, it's like 2 for the price of 1. So what happens in this problem is you have a tank that's shaped like a cylinder, right? And one part of the problem says, find how much work is done to empty the tank if the cylinder is upright. Yay, life is good. Then of course, it says, now do the same thing if the tank was laying on its side. Okay? All right. So, I'm just going to give you a little hint, a little boost, a nudge. I'm going to give you a nudge, okay? Okay, I'm not even going to touch this one. You guys can all do the cylinder. I know you can. We can find the cross-section, vary the cross-section of that cylinder. So let's talk about the area of a cross-section of a cylindrical shaped tank that is on its side. So here we go. Oh, that's a pretty good circle. All right, so we have a circle. Other end is another circle. There's our tank. If, say, our fuel level is here. I hate the fact that this.
Today would be the perfect day to go outside in this price.
Actually true. Sean, what did the... Sean just gets so savage.
Okay, that's because he said he doesn't know who else.
All right. So,
Thank you, Kelly. Thank you.
it's hard to picture. It's a terrible drawing. Can you draw it? There's if you can picture, what would the shape be of a cross-section of the fuel in the tank at any given Y
It's
value?
got flat rectangle.
It's going to be a rectangle, right? Okay. It's a lot like the problem we did previous. The length of the rectangle is going to be a constant. The fun part is the width of the rectangle, right? Okay. Now, the width of the rectangle, here's my nudge. I haven't given you the nudge yet. So here's my nudge. I personally did this by just writing the general formula for the equation of a circle, right? X squared plus y squared equals r squared. Solving it for x so that it's in terms of y. And then I get, because remember, any of these points, like I pick any point, right? Right, that would be, if that's our center, right? That's an x comma y value, right? So it's, I just double that distance from that x value, and I've got my width, right? There's one gotcha. The gotcha is the fact that if you do that, you have to remember if you center the circle at 0, 0, this is y equals 0. So when you're doing your limits, you can't go 0 to whatever, you have to go negative something to something in order to do it right, because it's centered at 0 is the center of the circle, not the bottom of the circle. Does that make sense? Okay, good. All right, so here's what we're going to do. First, we're going to shut off the camera.
Hit me up on Insta.
But